Good morning, Algebra 1 CP students. This is a lesson for my B-Day classes for April 20th and my A-Day classes for April 21st. In this lesson, we're continuing our work with polynomials. Actually, we're going to be working with them for the rest of the year. So they are these mathematical objects that have some of the properties that numbers do. So we'll begin by just reviewing what polynomials are and review naming them. Then we talked about multiplying and squaring polynomials. We're going to review multiplying three polynomials. We're going to cube polynomials, which means raise them to the power of 3. And then we're going to start, so the next thing on the agenda is dividing. And then after that, we're going to be doing factoring. So the same way you can factor numbers, you can factor polynomials. It is a difficult topic, but we first have to review multiplying and just talk a little bit about dividing. So divide polynomials by a monomial. Okay. So let's review what polynomials are. A polynomial is the sum or a difference of one or more monomials, one or more algebraic terms. So this is an example of one, 6x squared plus 5x plus 11, okay? A degree of a polynomial is the power of the highest degree term. So this polynomial has degree 2 because the highest power is 2. The leading coefficient is the real number multiplying the variable with the highest degree monomial. So in this case, it would be 6 is the leading coefficient. Now, there are some commonly used nicknames for different degree monomials. If something is 0th degree or just a number by itself, we call it a constant term. First degree, we call it a linear term. Second degree, we call it quadratic because of square. When you raise something to the second degree, you square it. So that QUA results in the name quadratic. Third degree term is cubic. Fourth degree is quartic. And then fifth degree is quintic term. And then commonly used nicknames, if you have a polynomial consisting of just one term, it's called a monomial. So this is an example, just a 6x squared. If you have a polynomial consisting of two terms, you call it a binomial. So 6x squared plus 5x is an example of a binomial. If you have a polynomial consisting of three terms, we call it a trinomial, 6x squared plus 5x plus 11. There are nicknames for things that are larger than fifth degree and that have more than three terms. They are just a little bit obscure, so I'm not listing them here. You can say just sixth degree or seventh degree, just call them by what they are, or 4 terms, 5 terms, and so on. All right. So for problem 1, for each polynomial, state its degree, the number of terms, the leading coefficient. Then name the polynomial with a full name. Okay. So first you have a equals 6x squared. So the degree is 2 because the power on the variable part is 2, the highest power. The number of terms is 1. You just have one term, 6x squared. The leading coefficient is 6. So the degree is 2, which means it's quadratic. Number of terms 1, which means it's monomial. So it's called a quadratic monomial. The degree name comes first, then the number of terms. It's just a naming. It's just a naming convention, okay? It's not like a natural law or anything. So the full name is quadratic monomial. Part B, 3x cubed plus 6x. So the degree is 3 because the highest power is 3. The number of terms is 2, 3x cubed, and 6x. The leading coefficient is 3 because the number multiplying the highest degree term is 3. The full name, degree 3 means cubic. Number of terms 2 means binomial. So it's a cubic binomial. And then part C, x cubed. The degree is 3. The number of terms is 1. The leading coefficient is not 0, it's 1. Because when there is nothing in front of a term, there's no coefficient in front of it, or there's an implied 1. So degree 3 means cubic, number of terms 1 means monomial. This is a cubic monomial. All right. You wouldn't want to study math if you didn't know what an odd or an even number is, right? So the same thing with polynomials. You want to know how to classify them just so you can understand their properties better. It would be a handicap if you were doing math and not knowing what an odd or an even number is, or a positive or a negative number is. So the definitions are important to help us understand these things better. All right, so that's problem 1. All right. Okay, so let's jump to multiplying these things, I think before Easter break, we multiplied one term by many terms, and then many terms by many terms. So in this case, we're going to be multiplying 3 binomials, right? So x plus 3 is a binomial, x plus 5 is a binomial, x minus 1 is a binomial. You're going to be multiplying 3 polynomials, which happen to be binomials. So I did say polynomials behave in the same way as numbers. If you want to know what to do next, or kind of to anticipate what to do next, ask yourself, what do you do when you multiply 3 numbers? So if you're asked to multiply 2 times 3 times 10, well, you can do one of 2 things. You can, 2 times 3 times 10, you can multiply the 2 and the 3 first. So the first pair, get a 6, and then 6 times 10, get a 60, okay? Notice I didn't do 6 times 20. I didn't multiply 2 by 3 and then 2 by 10. You multiply 2 things at a time. Or, right, or you can do you can multiply the last pair first. 3 times 10 is 30, and then multiplied by 2 to get 60. Both of these things are okay because multiplication is associative. This is the associative property of multiplication. You can multiply it. If you have a bunch of things multiplied, you can multiply it in any grouping, and the result will be the same. That's the that's what that says. Okay, so you can do the same things with polynomials. All right, so the first thing I'm going to do is rewrite the problem. The quantity x plus 3 times the quantity x plus 5 times the quantity x minus 1. So my choice is, do I multiply the first pair together, or do I multiply the last pair together? For this example, I chose to multiply x plus 3 times x plus 5 first. So what's going to happen to the x minus 1? Well, so equals, the result of multiplying x plus 3 and x plus 5 is going to go in parentheses, because I still have to multiply that by something else. So the parentheses are important here. And then that x minus 1, I just copy. The same way that when I was multiplying 2 times 3 times 10, I multiplied 2 times 3 to get 6, and then I just wrote the 10 before, right? I just wrote the 10 next to times 10 next to the 6. Okay, so I'm just going to write times quantity x minus 1. All right, so the question is, how do I multiply x plus 3 times x plus 5? Now, I know it's been a really long time, more than a week, but if you're multiplying 2 things by 2 things, you basically distribute, but you distribute one term at a time. All right, so we're first going to multiply. We're going to first distribute the x. X times x is x squared. And we're going to distribute the x again. X times 5 is plus 5x. So we're going to forget about this plus 3 for a while. So x times x is x squared. X times 5 is 5x. And then we're going to forget about the x and distribute the 3. 3 times x is 3x. 3 times 5 is 15. So you get that in parentheses. So now you have this polynomial times the quantity x minus 1. Before I do anything else, let me combine like terms. So x squared, there's no other squared terms inside the parentheses. 5x times plus 3x is 8x. Remember, when you add like terms, you don't change the variable part. And then plus 15. And then times x minus 1. All right, so now I'm going to multiply x squared plus 8x plus 15 and x minus 1. So I'm multiplying 3 terms by 2 terms. What am I going to do? I'm going to distribute first the x squared, then the 8x, then the 15. All right, here we go. So x squared times x is x cubed. X squared times negative 1 is negative x squared. All right, now I'm going to forget about the x squared and focus on the 8x. Going to distribute the 8x. 8x times x is negative 8. Oh, wait a second. Okay. 8x times x is 8x squared. And then 8x times negative 1 is negative 8x. All right, I'm going to now forget about that and focus on the 15. 15 times x is 15x. 15 times negative 1 is negative 15. Okay, there you have it. Notice I didn't put parentheses around it because there's nothing else I'm multiplying this by. Just as a general rule, if you still have to multiply a number, a fraction, a polynomial by something else, put parentheses around it to remember to multiply everything inside it. All right, so now, I mean, this is a perfectly fine answer, but let's combine like terms. You only have one x cubed term. Negative 8x squared plus 8x squared is positive 7x squared. Remember, you don't change the variable part when you are just adding like terms. Negative 8x plus 15x, 7x, sure, plus 7x, and then a negative 15. So that's it. The biggest mistake is that students just keep on going. All right, you kind of condition in middle school that all answers should be just one thing, one number, one variable, one shape. So they'll just keep on adding things and just kind of come up with their own rules for algebra in the process. These are unlike terms. You can't add these. This is a cube. This is 7 squares. This is 7 lines, and this is 15 dots. Right? This is 3 dimensions, 2 dimensions, 1 dimension, 0 dimensions. So you're adding, like, you have different objects. You can't add them. All you can do is just list them, how many you have of each. Okay. All right. So and then at the end, let's state our result and kind of say what we did. We multiplied 3 polynomials, and the result was 1 polynomial. Okay. All right. Kind of like multiplying, remember in middle school, 3 numbers? All right. 3 2-digit numbers. All right. That's a topic in middle school or elementary school. All right. Here we go. All right. So